Okay, so we're looking at a topic again in rates of change called time distance graphs, and we're going to go through some basic shapes and then we'll get some problems after that. Okay, so along the bottom we're normally measuring time, and on the vertical we're measuring distance, and the distance is from the origin, and the origin might be defined as A, or the origin might be defined as your home or wherever, but it's a distance. Okay, so what's happening is this person is moving away from A to some distance, whatever, X, or some distance, and then the distance isn't changing for that period of time, so the thing is not moving, and then this isn't representing downhill. All that's happening is that this time it's coming back to where it started. So this position here, you're back at A because that line along here represents A. So we're not representing a journey up and down a hill. We're representing a journey from a particular spot, A. So copy that down and come across with me, and we'll do a few more. Okay, so let's have a look at it again. So we've got distance from some place, origin might be home. Okay, so trying to connect it with what you've just done. So this is a curved line, so it's not a constant speed, and it's getting quicker, which means that it's accelerating. Okay, so it's curving up, so it means it's accelerating. Then we've got a straight section, so the slope gradient shows a constant speed between, this position here and this position here over a certain time. So if you have to calculate the speed, if you have to calculate its distance over time, so we can work out the speed. And then this is another straight section, so it's a steeper gradient, so it's still constant speed because it's a straight line, but because the line is steeper, it's faster than down in this position here. And then wherever we are away from home, at this position here, we've got this straight line horizontal, which means the thing has stopped moving. Then we've got a straight line again down to about there. It's a constant speed, but it's heading back towards wherever we started from. Okay, and then here it's still coming back towards the home, but it's slowing down. It's decreasing at a decreasing rate, so it's decelerating. Over this side it was accelerating because it was getting quicker. Here it's slowing down, so it's decelerating. Okay, so copy that and we'll do a few more. Okay, so let's talk about what's here. We don't know what this place is, but we've got kilometers, so we've got 10, 20, 30, 40, 50, 60 kilometers, and the time of the day. Okay, so the particle is starting at 0, it's going to 20, so the speed is 20 kilometers, and it's going 1, 2, so it's going at 10 kilometers per hour. Okay, till 10 o'clock. Then for 1 hour, it's stopping at the 20 kilometer mark, wherever that is. Might be a shopping center, who knows. And then at 11 o'clock, they're getting back into their whatever their vehicle is, and they're going from 20 to 60, so it's going 30 kilometers, and it's taking 1, 2, 3, so it's taking 3 hours. So the speed is 30 over 3, which is again 10 kilometers per hour, so it's the same speed. And if you had a look at the slope, that angle there is the same as that angle there, so the slope is exactly the same. Then at 2 o'clock, it's having a rest for an hour, wherever that is. It's at 60 kilometers from home, it's having a rest for an hour. And then in one long continuous journey between 3 o'clock and 5 o'clock, so in 2 hours, it's going from the 60 position all the way back to the 0 position, so it's going 60 kilometers in 2 hours, so its speed is 30 kilometers per hour, but it's heading towards home. Okay, so all these journeys on this side were away from home, and then this journey is towards home. There is no hill. This person is not climbing a mountain and then falling down the mountain. It's just journeying away from home and then back towards home. So down the bottom is always time, and on the vertical is always distance. Okay, and you can actually measure the speed by doing distance over time. Just remember, speed equals distance over time. Okay, so copy that and come across. Okay, so here's another one for some journey. So this is in England, Preston, Formby and Liverpool. Okay, so I'm assuming that Liverpool is at that position at the top, Formby at 40 and Preston's at 0. We've got 8 o'clock, 10 o'clock and lunchtime. So can you answer those questions on the side? So the journey shows a journey made in a car by a family between Preston, Formby and Liverpool. Look at the graph and then answer the following questions. So have a go and see what you get. Okay, what time did the family arrive in Liverpool? So Liverpool is up there. So Liverpool, so A, the answer is 10 o'clock. B, what is the distance from Formby to Liverpool? Formby to Liverpool, 40 to 90, so the distance is 50 kilometres. C, how long did the family spend not moving? Well, the family wasn't moving up there and the family wasn't moving there. So 8 to 10, so that's 9 o'clock. So we've got from 9 till 9:30. So we've got 30 minutes for that first part. And then we've got, that's 11 o'clock. So we've got an hour there. So the answer is 1 hour 30. Okay. And then D, the last part. What was the average speed on the journey home? So the journey home was from 90 to 0. So speed equals distance. And it took 1 hour. So this average speed was 60 kilometers per hour. And because it's a straight line, it's a, not you asked, but it's a constant speed. He didn't accelerate, he didn't decelerate, he was going constantly. Okay, come across when you're ready. Okay, so here's one that I've actually got the questions, the answers for. So we've got two people, Andrew and Philip, and their distance from home in kilometres, and then the times along the bottom. They're cycling on the same road, and they both stop for a 1 hour rest before returning home. So here's some questions you could get asked. So when did Andrew leave home? Well, Andrew is the green line, so Andrew left home at 10 o'clock. When did Andrew have his rest? Andrew is the green line, so Andrew had his rest from here to here, so between 12:30 and 1:30. Okay, 12:30 and 1:30. When and where did Andrew overtake Philip? Okay, so Philip is the red. So this is the place where they overtook each other, which is at 11 o'clock and at 25 kilometres. At 11 o'clock and 25 kilometres. What was Philip's fastest speed? So we're looking for the steepest line. So it's probably, this section here looks the steepest line. We could check the other lines, but that looks the steepest. So it's going from 30 to 20. So he's going 20 kilometres in the space of 1 hour. So his speed is 20 kilometres per hour. How far did Andrew travel altogether? Well, Andrew is the green line. He travelled out to 40 and then he travelled back to 0. So he travelled a distance of 80 kilometres because he went 40 out and then he went 40 back. And the last one, what was Andrew's average speed? Well, the time between 10 and 5 is 7 hours. He drove 80 kilometres, so on your calculator, 80 divided by 7 is about 11.4. Okay, so that's how you do travel graphs. Thanks, bye.